Hello, dear colleagues. Today we'd like to present the results of our research, the purpose of which was to evaluate the influence of linguistic preprocessing on the interpretability of topic models for literary texts.
Topic modeling is a machine learning method used to categorize large and structured text data. It seems that topic modeling can become an effective way of solving the current tasks of modern humanities. For example, building a topic model of national literature, broadening the possibilities of digital humanities and distance reading methods, as well as developing the artificial intelligence systems that process large volumes of literary texts in any language.
This research continues a series of studies dedicated to the research of linguistic and topic diversity of Russian short stories in the first 3 decades of the 20th century. It aims to build topic models for 3 consecutive historical periods, each of these corresponding with important historical events. So the first period refers to the beginning of the 20th century before the First World War. The second period is the era of social cataclysms, wars, and revolutions. And the third period is the beginning of the Soviet Union's formation. It is assumed that the historical background of the era will be somehow reflected in language, content, and therefore topics of these texts. The quality of topic modeling results is affected not only by the algorithms behind the model, but also by the data preprocessing. The purpose of this research is to evaluate the influence of part-of-speech filtering of the data after lemmatization on quality and interpretability of resulting topics. An important result of this research is the assessment of the topic model in terms of its content interpretation.
9 samples were prepared for conducting the research, 3 samples of 100, 500, and 1000 short stories for 3 sequential periods. This was done to estimate the change of topic diversity in the dynamics. Since the ultimate goal of the research is to model the national literary process, when forming the sample, the main emphasis was placed on ensuring representation of texts for the maximum number of Russian writers who worked in the genre of the story. While forming the samples, 2 tasks were set. Firstly, ensuring a relatively even distribution of texts by the year of writing or the year of their first publication. And secondly, ensuring the maximum representativeness of different authors in both the whole period and each individual year. The samples of a smaller size were subsets of the larger samples.
While pre-processing, punctuation, digits, and function words were removed from the texts, the words were lemmatized using the RU-Core-News SM model of the SPACY library. For all 9 samples, pre-processing was carried out with different part-of-speech filtering options. Without any filtering options, with filters noun, verb, and adjective, with filters noun and verb, and the last one, with the only filter noun. Sample sizes obtained are represented in this table.
When building the topic models, we used the LDA, Latin directly allocation algorithm, which is a multinomial generative probabilistic model. In accordance with the LDA model, the corpus of text is considered as a mixture of topics. Each document in the collection is described by a set of hidden semantic structures, topics, which in turn are composed of words that contribute to it with a certain degree of probability. A document can have an unlimited number of topics. Regarding topic model evaluation, 2 aspects are mainly considered. First, how interpretable the resulting topics are, and second, how well these topics describe the collection of documents in question. Perplexity evaluates how different and evenly distributed words are in texts. The less perplexity, the better the model. Another measure, coherence, allows determining how often words that occur together in one text fall into the same topic. The larger coherence, the better it is. This table presented in here is summary statistics about the trained topic models for 9 samples with 4 different preprocessing conditions, including the optimal number of topics, perplexity, and coherence for each model.
Each topic is a list of 10 words sorted in descending order of the probability that a word belongs to this topic. An example of a topic model obtained for the first period and 1000 short stories without the use of part-of-speech filters, with the number of topics equal to 15, is presented in the table which you can see on the slide. A total of 36 such models were obtained during the experiment.
The next stage of the study, the task was to assess the expert interpretability of these models. 3 philologists with both literary and linguistic backgrounds were invited as experts who had to independently assess interpretability of all topics obtained for all models on a binary scale, interpretable versus uninterpretable, and then the degree of consistency of responses for each model was analyzed. Thus, in the experiment conducted, the degree of rigidity of the assessment among experts turned out to be different. Because of this, we do not have many topics that are considered to be interpretable by all 3 experts, but this in no way affects the solution of the problem assigned in this study, since all 36 models were described by the same experts working in parallel and independently. This table presents the results of the assessment of the interpretability for the obtained models by 3 different experts.
The table on this slide shows the proportion of topics for each model that were determined to be interpretable by all 3 experts. In general, it is the models built without part-of-speech processing that show the best average value, more than 11% of interpretability. Thus, based on our material, it wasn't possible to obtain an unambiguous conclusion that one or another preprocessing option is significantly superior to all the others. But one can argue about some advantages of building models without any part-of-speech filters, which on average gives performance that is in almost 2 times better compared to other preprocessing options.
The study allowed us to evaluate how different options of text preprocessing affect the quality of topic interpretability obtained in the result of expert assessment. The results showed that when building topic models using the LDA algorithm, among the tested preprocessing options, there was none that leads to optimal results for all text samples. However, in general, a better result is shown by topic modeling without any part-of-speech filters. Another conclusion of our research is a suggestion that the interpretability of the topic model built on a collection of texts depends not only on the considered preprocessing options, but also on lexical and stylistic homogeneity of the collection of texts under consideration.
Further, a specificity of the research was the fact that experts, when assessing the interpretability of a topic, took into account only the set of words that form this topic and their probabilities. But, as is usually the case with topic modeling, they did not refer to the original literary texts. It seems that the continuation of research should be seen precisely in the combination of formal methods and the analysis of literary works themselves. But it is this approach that can serve as the basis for constructing an optimal system of keyword annotation of literary texts.
The research was carried out within the framework of the Academic Fund program at the National Research University, High School of Economics in 2021. Thank you very much for your attention. Now I'll be happy to answer your questions.